what should I get? You take the antiderivative.
3 over 2 sine of something. And 3 over 2 sine. Yeah, you should just get the 2. So, wait.
So the antiderivative of the derivative is f of x, right? What was f of x?
Sine 3x.
Plus chow.
You did plus chow?
Chucky.
Where you said chow. I was like, what? His name changed. So you just leave it.
I'm just showing, we're just saying, oh look, if I take the derivative of this,
I'm just going to get something.
yeah, and if I go backwards, it's going to be the same thing.
So wait, you're saying you're trying to come today?
So, f prime of x of this next one. How do you take the derivative of e to the cosine of x?
It'd be
you take cosine of x times sine of x. Negative sine of x.
Oh, the derivative.
Yeah.
Okay.
So I'm going to put this out here. So negative e cosine x times the sine of x.
So it's the antiderivative of that.
So I take the antiderivative.
Are you just going to say we got that and then move back to it?
Yep. So what's it going to be?
E cosine of x.
So
You'll see.
It's either between your class and my class.
I don't think the lane's carried.
What was yours called, Fizz? Ours is the greatest.
Oh, could you
What's
tell
yours then?
Rate of pride or something?
Yeah. I didn't like yours.
Okay, so pattern recognition.
I don't have one.
When we took the derivative of f of some composite function, it was just f prime of what was g of x times what?
G prime of x.
G prime of x.
Partial credit.
Are we just...
So would it be
Yes.
divided?
So if you turn around and anti-differentiate that, what you should see, or what you should eventually have to have, is this part right here. This g prime of x, what you're doing the f prime of here, should be in there. If it's not in there, we're going to have to put it in there to go backwards.
Do you have, like, are your notes like already written up and you just erase them, or do you just type them as we go?
They're written out and printed.
Like, is there a way you can post pictures of them? Like, the full set?
Oh, yeah.
So that if they wanted to go look back at it, they could.
At the other ones,
Yeah, like if I wanted to do the rest of it.
Yeah.
yes.
Okay.
Oh,
Well, I'm at home all week.
oh wait.
I'm gonna be busy.
Are we going to have
You're gonna be asleep.
a
No, I
test
need
over
to
this?
clean the house and then get seen.
Not at least until after May 4th.
But yeah, can you post the notes then?
Okay. All right. So, for example, this 3 cosine of 3x on the next page. Okay, so you have the cosine of 3x. That's like your f prime of x. And then we took the derivative of 3x and got this 3.
Yes.
So the antiderivative from sine to cosine, or derivative, sorry, from cosine is negative sine. So how do I go backwards?
It's just gonna be sine.
Be negative cosine.
We'll find out in that.
Shouldn't it just be sine?
Right. Well, because this is the derivative. This is the way we learned it. Okay, so it would be the sine of 3x plus check.
Oh,
That's it. You just drop the coefficient.
wait, yeah, where'd the 3 go?
We should drop it.
Same place where it
We already
went.
did this problem.
Where we went, yeah, right here.
I recognized it when we looked at it, but I thought we were actually going to do the math for it, but apparently not.
I did too.
So, like,
It's coming. The math is coming. I swear. Okay.
wish that could just be the math right there.
Okay. So here we have the sine of 2x
Thank you.
plus 3.
So is it going to be the cosine of 2x?
And the antiderivative of the sine, the derivative of 2x plus 3 is this 2. So that's already there. So yes, it's going to be what?
Negative cosine 2x.
Negative cosine of 2x plus 3 plus check.
Wow.
It'll get harder in a minute.
So now there's not. So now we have to put in
Okay, good.
3.
So now the next one, here's the problem. Yeah, notice you have a cosine of 3x plus 2.
This is going to be.
And when we take the antiderivative of 3x plus 2, or not antiderivative, derivative of 3x plus 2, what do we get?
3.
3. Let me change the color here.
This is going to be.
So I need a 3 here.
Uh-huh.
I can't just put a 3 there.
Well, I can.
You can.
Yeah. I mean, if it's a
So in order to put a 3 there, I need to put a 1/3 out here.
Oh, so now it's the average. Kind of.
Because now I'm multiplying just really by 1.
So we are just putting the 3 there.
We are just putting a 3 there, but we're also putting a 1/3 out in front.
Gotcha. So now it's just cosine of, or
So
negative sine of.
So now I have to bring down the 1/3.
Sine.
And the antiderivative of cosine,
It's just sine.
Negative sine.
cosine is negative sine.
Oh, the derivative. I remember.
No, antiderivative, you're right. Cosine is sine, you're right.
Oh,
Yeah, I was doing the derivative. It is 3x plus 2 plus check.
Okay, so this next one.
Yeah.
5 is not the derivative of
No.
1.
So we have e to the 3x. I'm just going to put this 5 out here, okay?
That's fine. We'll just suspend it. So we're going to do like another 3 and 1.
Yeah, so look at the 3.
Mm-hmm.
Derivative of 3x is 3. So I really need a 1/3 out here.
So 5/3.
So it's 5/3. Very good. So it's 5/3. What's the antiderivative of e to the something?
So just 3x.
it's
The derivative is.
it's ln. No, it's
What's the derivative of e to the x?
E to the 3x times x.
What's just derivative of,
derivative of the top times all that.
The
what's the derivative of e to the x?
E to the x times x prime. X prime.
Yeah, it's just e to the x, right?
Sure. So just 3.
Yeah, times x prime, which is 1.
So 3.
So this is just e to the 3x.
Yeah.
Plus check. We're still going to do a few more of these.
Wait.
I love
No,
7.
Okay.
I played it in the car
It
with,
was so fun.
Okay, let's go back up here.
on Friday. I played it in the car with Jacob, Jacob, Dorian, Juan, and they all were so happy.
Okay, so we have the thank you. So we have the cubed root of x squared plus 5, which I'm just going to rewrite it this way: 2x cubed. Oh, X squared plus 5 to the 1/3. I just rewrote.
So 2x is the derivative of...
Okay, so we have the nice, neat little derivative of my x squared.
Chunk it, get it out.
So yeah, it's like getting rid of it. So now I can just take the antiderivative of x squared plus 5. So x squared plus 5. I add 1 to 1/3.
4/3.
So that's 4/3. I divide it by 4/3.
Would it be 2x plus 5? Or, no, it'd be...
No, the 2x was here.
We got rid of it because it's a derivative.
Antiderivative. But yeah, just like here with this 3x, we got rid of that 3. That's called, think of that as a license to differentiate.
Wait, can you go back up?
Yep.
What is it? WST feel like you can't take the heat.
So, why do we still have the 5?
Because it's in the circle.
parentheses.
That's true.
Why not the x squared
Okay. Here's what I'm going to do. I'm going to show you a different way.
Yeah, where did the x word go? Hold on.
Okay. Here, let's do it this way.
Because I wrote the x
We're going to do it, I'm just going to do it this method. It's called use substitution, which we are going to do for the harder ones anyways.
Okay, cool.
So,
Okay, hold on.
your,
It's coming up.
when you use the composition of a function, when you would take the derivative of it, you'd have to use the chain rule. The function that you would have to use the chain rule on, that's what you set equal to u. So u for us, for this problem, would be the x squared plus 5.
So use the thing on the inside.
Use the thing on the inside, yes. Then we do the derivative of u, du.
Is equal to 2x.
2x.
It's just 2x dx. Because you also had to take the derivative of x with respect to x. Okay, so what we're going to do is we are going to replace this x squared plus 5 with u. So that's the cubed root of x squared plus 5, or cubed root of u, so u to the 1/3. And then this 2x dx, I'm going to replace with du.
Oh.
We'll start there tomorrow on Google Classroom.
Online.
Huh. That's making more sense.
Okay, sorry, I should have done it that way.
Well, I guess we got wins. And Daniel has something else first.
What?
Who won?
We did?
No,
Who
not
did?
that I know of.
She's just saying she gets